Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at this IBM PC 5160. It's an IBM XT. This machine's not turning on, so I want to figure out why. And I think I have a hunch at what's wrong, and I think it'll be good exercise to try to fix it and show everyone what a really common problem is with these machines. So, without further ado, let's get right to it. It goes without saying, first step is to take the cover off and take a look inside. And there it is, the inside of the 5160. Pretty run-of-the-mill stuff. We have an IBM power supply. We have a Seagate 277R, so this is an RLL hard drive, a standard Tandem full-height 360K disk drive. It's IBM branded. For the peripheral cards, we have an RLL hard drive controller. It's probably a Western Digital type. Let's take it out, it's not screwed in. Yep, just a standard Western Digital type controller. There's a Hercules monochrome graphics card here and printer port, actual Hercules branded, so that's kind of cool. There's a standard IBM 360K floppy drive controller card. And finally, we have a standard DB25 serial port. And it has the capability of having a second port, which I guess connects up to this header here. It looks non-standard, but the ICs are not populated. Right here is the system board, and it's a genuine IBM part, 256K to 640K. And pretty much everything about this machine is run-of-the-mill. The only thing that I haven't seen before is the speaker bracket is this beige color. Typically, this is sort of a rust brown color plastic. Slightly unusual. Looking at the date codes on these ICs, this machine appears to have been built around 1986. That seems relatively late in the XT line, but they probably kept selling this machine for quite a while and the price just kept dropping while people could opt for the PC XT, the 286, or of course other machines. But it wouldn't be too long after this that the 386 came out, so that would start to mean that this XT was really bottom of the barrel at 4.77 megahertz. Now, because this has the regular IBM motherboard, that means one thing about the problem it's having not turning on. I'm gonna guess that this machine has shorted tantalums. Now, they may not be on the system board. It's possible they're on the disk drive as well, or even the hard drive, or one of these system cards. So I'm gonna say the right approach for trying to figure out where the short lies is first, remove all the cards, disconnect all the drives, and start checking the power rails on the motherboard and looking for shorts. All right, so all you need to do this type of checking is get your multimeter and set it to continuity mode. Double check you have the beep working. We do. And then you can use the power connectors to look at the pins you're gonna need to test against. So, of course, the black wires are ground, so these 4 in the center. And then we're gonna check one of those. Those should be all connected together to all the other wires that have a color on them. Usually I find these shorted tantalums on the motherboard, which are these little caps right here, are typically on the 12-volt rail, which is this yellow wire, and I think this orange wire. This might be negative, but it's also worth checking against all the other colors as well. So I'm first checking continuity on the ground pins, and I have it. All right, so with the probe on the ground pin, first I'm gonna start on the 5-volt rail over here, and it just gave me a quick beep and it went up to 480 ohms, so that's fine. And now the yellow wire, here we go. No, there's no problem there. So this yellow wire right here was fine, and these red wires was 480 ohms. So let's check the other side now. Nothing, nothing, nothing. All right, so looking at this connector here, which is the one I was just testing, this blue wire here is shorted. And when I put the probe on there, 0.74 ohms. So we have a dead short right there on that pin. Now, right here on the power supply, IBM was nice enough to label what's what. So P8, that's what I was looking at. So that's this one. And we have a short on the -12. Now, it's easy to figure out what's what because the 2 black wires here are pins 5 and 6, ground and ground, and then the 4th pin was -12. And that's where the short lives. Now the power supplies that IBM put in these machines have pretty good protection in them, meaning they have current sense resistors on all of the rails, and as soon as they detect an overcurrent situation, the power supply will shut down. So if you have one of these old IBMs, 5150, 5160, or probably a 5170 even, and it just shuts down immediately like it worked and then it now no longer turns on, it's probably a shorted rail with one of the tantalums. Now, negative 12 volts is not needed for operation of the motherboard. It's available to the ISA slots as like a bias voltage. So if I take this blue wire out of this connector, like I remove the pin, then this machine will actually work, but that won't be available to the cards that need it, and usually like the serial cards will use that for RS-232. So I wouldn't recommend just pulling the wire out, but it is a way to get your machine working if you need to. All right, so now to find this shorted tantalum, I gotta remove the motherboard from the case here. I think on the XT, there's one screw here in this corner, and then there are standoffs. I think everywhere else, it's possible it's screwed in under the disk drive though. I don't quite remember. We'll figure that out quickly once we remove this, this screw here. So does this move? So it moves, but seems to be sort of stuck over on the bottom side here. And I think there's a screw. Yeah, the screw's right there. It's not hidden under the disk drive. So just make sure you take out the two screws that hold the motherboard in. Okay, now this should come out. Just disconnect the speaker here. If you've never taken out an XT or an AT motherboard with these plastic standoffs, well, they're annoying. You just sort of fiddle with it and eventually it will pop out. All right, we're over on the bench. Now we got to figure out which cap is shorted. Now, believe it or not, this is actually not as hard as it might seem. You need the multimeter again, and we're going to use the ohms range to figure out exactly where the fault is. Now, on continuity mode, the first thing you want to do is you want to zero out the multimeter. So I'm going to hold the probes together and notice there's a little bit of resistance there. So we're going to hit the relative button, and that zeroes it out. So that means that any resistance that's in these leads here is going to be filtered out. And what we're going to do is we're going to figure out which caps on this board are the ones on that negative rail. And there aren't going to be that many because, like I said, negative 12, and I think even positive 12 is really only used in the slots. It's not going to be over here. So we just got to figure out which caps are the ones that are relevant, and then we're going to figure out which one of those is shorted. Now, flipping this over, check out these bodge wires, IBM. It's neatly done, but I'm a bit surprised that by the time this computer was made in 1986, they had problems that required bodges. And I just noticed something. What the hell is going on with this ROM here? Why is it installed into additional sockets? Oh, that's a clock. That's what that is. Let's just pop that out. You could get a real-time clock that installed into the BIOS socket under your chip, and you can still get modern reproductions of this, and it was a common mod that people did, and that's what this is. Definitely what this is. I think Dallas Semiconductor actually made this, or they sold one, but I know other companies did as well. And almost certainly this chip is probably dead. Well, it's got a little battery in there. Yeah, look at that. It says SMT Inc. And on the bottom here, see it's all epoxied? There'll be a battery in there. So it's pretty certain that this is not going to be functional. So I'm actually going to take that out and we'll just put the BIOS back into the motherboard. I think it won't matter. It doesn't cause an issue if this is installed. It just obviously won't hold the time anymore. Okay, back to the fault at hand. So I'm going to clip on a clip lead here, and we're going to clip onto the 4th pin over. This is the one that's shorted. But with that clip lead on there, we're going to flip the board over, and I'm going to look at all the caps, and we're going to try to figure out which ones are in play here. Now, when you're trying to figure out which caps are in play, these tantalums IBM uses have 3 legs, and that's because they don't have a polarity. You can install them either direction. Now, because this rail is shorted to ground, I'm on the actual 12 volt pin, or negative 12 volt, but I can actually touch anything that's grounded, like probably right here, and it's going to have continuity. But that's actually a false reading because it's shorted through that cap. So the way we differentiate a cap that's on like a 5-volt rail or the other 12-volt rail from the one that's on the bad rail is we need to find one where all 3 legs are shorted. And that's going to tell us that's on the negative 12-volt rail. So this one right here, shorted. The middle pin not shorted, and the outside pin is shorted. So that one is not relevant. Next one over here, middle pin is shorted, but the outside pins aren't shorted. So that's also not a relevant cap. This one here, same thing. 2 of the 3 pins are shorted. So like I said, for these larger yellow ones, which I have a feeling the larger yellow one is going to be the problem, I need to find one where all 3 pins are shorted. Now, there are also 2-pin caps, like this one right here. Obviously, we're looking for one of these where it's shorted on both, like 2 out of 2 pins. Let's see about this one. Shorted, not shorted. Here's one, not shorted, shorted. So we can rule out all of those of being a problem. Right here. So what I'm going to do now is just go through all the caps and use a Sharpie and put a little dot on all of the caps that I know are on the rail because either 2 out of 2 or 3 out of 3 pins are shorted. Okay, all right, I was just about to mark a cap right here as a problem. And I see something that looks a little bit out of the ordinary. There's a cap here that is incinerated. This one right here. So I'm not even sure if that's on this rail, but that cap is or was shorted and it is now blown up. So let me see if that cap is actually shorted. Yes, that is indeed shorted. And that's going to be on that rail. And even though it absorbed a bunch of current and obviously burned out like that, that was not enough to blow it open. And of course, those caps can just burn and be open and then the machine will work again. The cap will just no longer be effective. Now the one next to here, there's a 2-pin one, and that's also shorted. And it's a little guy right here. So I guess they use a large cap and a small cap right next to each other. So I'm just gonna mark that one. I'll put a little mark on the PCB for the burned one. All right, I've gone through all the caps and I haven't found any others, so I didn't even bother checking over here, but I went through these caps and the only ones that are on the minus 12-volt rail are those 2. So let's just double check which one of these is actually shorted, and we can do this without removing it from the board. Okay, so here we are with the multimeter and I'm back to using the probes on their own. So what you want to do when you're trying to figure out which cap is shorted is you're going to measure across the cap and you're going to find one of them should have a lower impedance. So right now, of course, I relative these out. So we're at 0 or 0.1 when they're together. So we're going to find these have slightly higher resistance and we should be able to figure out which it is. Now, normally you have like several caps around the board and say the shorter one's this one. Well, if you're over here and you're measuring, it's going to measure shorted because it's shorting through that cap, but it's going to be going through the traces and there's a certain amount of resistance in those traces and you'll be able to see that. So when you fall upon the cap that is the shorted cap, it will have the lowest resistance of all the ones that are on that rail. Well, the 2 caps that are on that rail are right next to each other, so I may not be able to tell which is actually shorted because the length of trace or whatever on the top of the board that's connecting these 2 is so short, it's almost nothing. But we'll try, we'll see what it is. Okay, so this is the 2-pin one here. All right, 0.6566, and how about the burned one? 0.63. So it was slight, but it was lower. And we kind of know which one is the fault because it's burned. But yeah, like that's the way I would have found it. So what I do next is oh, that's a bad tool. So let me get the right cutters. Where is the right cutter? This one I painted red here because the end is broken off. I have more new ones, but I like to use the old clippers when they have broken tips. And you can see the broken tip right there. So it just makes it really hard to snip things. I use these to cut things you shouldn't cut, like thicker wires and things that actually damages the blade. So that's why I keep one of the bad ones around. But I mark them up with a marker just so I know which is which. This one is good. So I'm going to use these to clip this one off the motherboard. Now, I'm going to try to keep some of the legs on there just because it can be very difficult to solder onto these IBM monitors, they use motherboards. They use very thick copper to flood fill the board, like for the ground plane. And because of that, it wicks the heat away so much. So when you remove a cap, and now it's gonna be hard to see, but I've left some of the legs behind, you can actually solder a tantalum right onto that spot using those existing legs if you don't want to take them out. Or you can take them out one by one with a soldering iron, and it's actually a lot easier. But there is that bad cap. I mean, just if I had just looked at the board with my eyes, I would have found that. So you could avoid doing all that troubleshooting by literally just looking for burned tantalums. But I've had plenty of times where they're shorted and the power supply protects itself before it burns the capacitor like this. So with that cap out of there, so 4th pin over and ground, there you go. It's no longer shorted, of course, and that's because that's gone. And this cap right here, of course, is not shorted any longer either. So now it's just a matter of reinstalling a cap in that spot. Now looking at these other ones, they are all the same. They are 106s. All you need to do is go to your phone, look up that number that was on those other ones, 106, and there it is, 10 microfarad, 16 volts. And of course, just, you know, use your brain a little bit. We know that was a 12 volt rail, so you need to at least have a 16 volt cap on there. 25 volt might be actually a bit more ideal even. So I am gonna try to remove these legs here. So I'm gonna use the soldering iron here and some tweezers. Oh, and actually look, pulled that out quite easily. And we'll do it here as well. That one came right out. I think the center one is what's on the ground plane though. That is gonna be more tricky. So we're gonna boost this temperature up. You really need a high thermal mass soldering iron, and that is not exactly what I have. Yeah, this is struggling. Sometimes adding a little fresh solder helps just transfer heat. Let's see if this is doing the trick. Look at that. That is not coming out. So even with this thing, and I boosted the temperature way up into the 400s, and that was still not coming out. And that's, again, because that center pin is on that ground plane. And IBM motherboards, they are so good for using so much copper, and it can be very difficult. So unless you have a very high thermal mass soldering iron that can get that heat in there, I highly recommend you actually cut the legs of the cap, and that way you can actually solder right onto them. I know it's not ideal, but it really can save your day. So unfortunately, I can't find a tantalum to put there. So I'm gonna use this electrolytic, and I'm going to solder onto that center ground leg. Now we have to remember that this is a negative rail, which means that the part that connects to pin 4 here is actually below ground. So when you're talking about a capacitor, we want the minus part of the capacitor to actually connect to the pin here, and the positive part to connect to ground. It's basically reverse of what you would do normally. And with the multimeter here, we can just double check that the center pin is definitely ground, and it is, and these outside pins here are gonna be pin 4, and it is. So I'm gonna quickly tin the cap here. And now that it's tinned, I can just stick one leg right through the motherboard. And there's the cap installed. I know it's a little ugly, but it definitely is gonna work. And indeed, we do not have continuity to the ground pins. Problem solved. So there we go. Short has been eliminated. And I have the motherboard mounted back in the case. Power cable is connected. I have the hard drive and the floppy drive unplugged from the power supply. And of course, all the cards are gonna be out. Let me turn on this machine and make sure that this thing is at least powering up now with no smoke or anything like that. Power supply is plugged in. Here we go. Oh, still making a horrible noise. Oh, and I just realized, yes, you can't power this up without having a load. Duh. So how is this for a load? A Seagate ST4053 full height MFM hard drive? I don't want to have this hard drive connected right here because it's got some data on it. I want to make sure I get off of it first. So in case the power supply is bad, this large hard drive is sacrificial, so to speak. Okay, here we go. No, still not working. Interesting, interesting, interesting. So it appears that the power supply may also have a fault. So I'm going to use my typical bench one that I use, which had long connectors for the motherboard here. we'll plug this in. And of course, AT and XT power supplies are compatible with each other. There's no issues using them interchangeably. And this power supply has no issue powering the board up without a hard drive connected. So let's turn this on. Okay, it's on. I heard a click out of the speaker. There it is. Okay, so this motherboard is definitely working. So let me repopulate cards so I can get this machine booting. Now when I power this on, it is possible, it's totally possible that one of these cards also has a short on it, because all of these cards do have tantalums on them, and unfortunately, the failure mode of a tantalum is to be shorted. And unfortunately, there could also be a fault on the hard drive or the floppy drive, so it's quite possible that plugging this stuff all back in could still result in a non-working machine. Okay, everything is connected. Let's try this again. Hard drive is spinning up. That all sounds normal. Now I don't have a monitor hooked up, obviously. Let's see if there's a disc in there. There is not, but we should hear it beep after it does the postcode or the count up. It's not gonna try to boot because I don't have a keyboard plugged in, but let me find a monitor to plug into this thing. That sounded good. I was over grabbing the RGB to HDMI here to hook it up. Yeah, it's seeked on the floppy drive, so yep, working. Now this machine did power up before it stopped, so I'm assuming that shorted tantalum is what started the problem, and it's quite possible the IBM power supply really didn't appreciate having that rail being shorted, and now it just makes a screeching noise when it's turned on. All right, the monitor's up, RGB to HDMI is up. I have it in Hercules text mode profile, and something weird happens. When I turn on the machine, everything turns on, but we're not getting video output. So I'm actually gonna turn this off, and I'm gonna swap in a different card. I think this Hercules card is faulty, actually. So that's what a genuine Hercules card looks like. I actually don't think I've ever seen one. Ah, kinda cool. All right, I have a VGA card in the machine. It still makes this beeping sound, even though I have the dip switches set correctly for the VGA card. I also have an XT IDE in here. It does initialize properly, it just came up there. The floppy drives made a horrible noise there. I think this computer is a bit of a basket case with a lot of other problems, and I don't think I want to get into fixing all of those issues on this video. I wanted to really show that you can find a shorted tantalum by doing a little troubleshooting with your multimeter, and I think I've done that, although yeah, this thing's not even booting. So there's a ton of problems with this machine. Nice, it appears my XT ID card isn't even working in this machine. It just goes right and boots into basic. And there we go, a little repair on the IBM PC 5160. This machine obviously still has a bunch of problems that I'm not going to be able to diagnose and troubleshoot in this video. I really wanted to show the methodology for finding those shorted tantalums, which are very common on the 5160 and the 5150s. I've fixed a couple of these now. So if you have one of these machines or something of a similar vintage that all of a sudden is not turning on, or you just acquired it and it also doesn't turn on, you should always check to see if those voltage rails are shorted. And if one is, hopefully you're armed now with enough knowledge to be able to go find the component that's causing the short and cut it out or replace it without too much trouble. So if you'd enjoy this video, I'd appreciate a thumbs up as usual. If you didn't, you know what to do, all the usual YouTube-y stuff, and subscribe, etc., etc. Check out my second channel if you haven't already. And a huge thanks to my patrons. Their names are scrolling up the side of the screen. You can become a patron as well at the link in the description. And I do have some exclusive videos and a little bit of exclusive content for my patrons, so it's not just early access to videos. So that's it. Stay healthy, stay safe, and I will see you next time. Bye.